Hello and welcome to our series on restoring a classic sailboat. The boat we've chosen is a 1983 Pearson named Athena Querida. My name is Finbar Murphy from O'Galley Boat Works here in Melbourne, Florida. I hope you will join us each week and follow our progress in restoring this beautiful boat to its original glory. We will not only restore it, but we will also update it with equipment and innovations which were not available when the boat was originally built.
Just finished creating an engine jig for this particular engine, where we do a mock-up of certain key surfaces on the engine for us to template off when we build the engine bed. This is the output flange on the engine, which corresponds on the jig, and this is your motor mount on the jig, which corresponds to where it belongs on the engine. The angle of our wooden jig corresponds to the angle of the transmission on our engine. We use the engine jig to ensure that we are within certain tolerances involving the targeting of the shaft on the boat itself and the output of the transmission. If the engine isn't aligned properly on the new engine bed and with the targeting of the shaft on the boat, you can have premature cutlass bearing wear, vibration, and a loss of efficiency on the engine itself due to friction within the cutlass bearing and the engine output. We use the engine jig to as a mock-up to create the engine bed within the boat and make sure that our targeting and alignment are within certain tolerances. Let's go to the boat. Alright, I've got the engine jig precariously put into what is soon going to be the engine bed. It's sitting right now real close to what the final alignment of the engine will be once we have an engine bed, including stringers and a captive bilge put underneath it. At this point, this is essentially a rough alignment of the engine within the engine compartment in relationship to the propeller shaft and the coupling. Now, what my next task is to do is to start taking measurements between the bottom of the engine mounts and the actual hull itself, so I can get an idea of how big or tall my stringers are going to sit from the actual hull, the inner hull of the boat. And looking right now, I see that I'm going to be coming up about 8 1/4 inches. I'm going to check all 4 corners of my engine here, because this engine jig is a mock-up of the engine itself. Because of the hull, seeing as the hull tapers down to the keel, the distance between the bottoms of my motor mounts on this engine on this corner, the forward starboard corner, is about 3/4 of an inch more than that of my aft starboard corner. This particular engine jig is off of and for a V-drive engine, which can confuse people when they're doing the installation, because the entire engine is turned backwards, and what is the traditional back of the engine is facing forward in the boat. This configuration is done with the transmission, the V-drive transmission, and it allows for a much tighter engine compartment and gives the boat itself more space aft of where the stern tube is. That's her. And once I get that up in here, I'll put the engine jig back on it and maybe sand a little. My triangles, what I'll do is I'll loosen my clamps a little and tap it so that the way the stacked up plywood starts taking the shape of the taper of the hull here. And then once I'm real close, what I'll do is I'll tighten the clamps down on them and laminate all those together with the West system that I'm going to be using. It's an epoxy. That is boring as hell to watch. Small.
Tis the season.
Please.
Charlie,
We'll be good for a few hours at least.
peace to goodwill.
Jack has, or somebody came up with the idea of coming out of commercial breaks singing Christmas songs. I don't know if that's a good idea.
I've been
Coming out of the breaks. We'll come out of the breaks with our regular music.
I think if it's Jack's idea, Jack should do it. The past 2 weeks I've been walking around the hallways, and I know after like the first line or two out of a song, I'm really lost.
Well, I've got a whole list of songs here, so maybe every so often I'll just pick on somebody and say, okay, start singing Santa Baby.
Santa Baby by Kermit the Frog.
Earth the Kid, Earth the Kid. Well, it's the same thing.
I know.
I want to welcome him to the program. He's a very nice guy. Welcome him to the program. They're going to be sponsoring the file for a while. And so I took the opportunity.
Different enough to if not what it is.
We could pull that.
Jeez. Actually, if it's in the water.
Some 2 wooden stringers. Take one. Action.
Okay, we've gotten to the point where we've taken our previously made cardboard templates, as you can see here, and turned them into wood templates. Or actual, this is going to be the stringer once it's laminated together and then glassed over. When it's all squeezed together and laminated and glassed over, it's going to be as solid as a rock. You can kick it, stand on it, do whatever you want, and it is not going to move. We've used 3/4 inch marine grade plywood. That's one of the reasons why we make cardboard templates first, because at about 88 something and change wholesale for a sheet of this stuff, you don't want to make any mistakes. It'd be a waste of wood. There are slight imperfections in the height of this soon-to-be stringer, which later on are going to be worked out with a combination of putting in the high-density filler and then smoothed off with a grinder. Later on, when we have both stringers made out of wood, we'll then check it on the engine jig, go through and look over the alignment at the stern tube and over by the transmission. Also, what we have here is some fiberglass tubing that's going to get glassed into place to allow liquid water to drain from the aft of the boat to the keel, back down into the bilge. The reason why we're making these limber tubes or limber holes, whatever you want to call them, is because there's going to be an area underneath the engine which is called the captive bilge. That's to keep any kind of dripping oils or engine fluids of any kind from getting into the bilge and contaminating the environment. area of wood is going to get removed later on. I'm giving it to look like kind of a castle. It's actually known as a castled engine bed. And I'm drawing these lines to indicate where I'm going to start removing material from once it's all laminated together. And this is piece 1, 2, 3, 4, and 5. I got them numbered because slowly, by about 1/4 inch each piece of ply, it's 1/4 inch shorter to accommodate for the taper in the hull back here.
Yeah.
I've marked and numbered the raw stringer wood here because later on what I'm going to be doing is removing material between these two lines so that the boat owner can get their hand, or a technician can get their hand under the engine if need be, to actually access the shaft packing, which we've discussed earlier. And they're also, the reason why I have them numbered is because each individual piece of plywood has a slightly different measurement as you move outward of the center line of the boat, because there's a flare to the actual hull of the boat.
Action, last step. Action.
Once we've completed putting in the raw wood stringers, we are then going to spend a little bit of time shaping it with a grinder to smooth over any edges that would cause the fiberglass matting that is going to go over it to bubble. And that's the thing that would cause sort of leakages to get into the wood. You know, fiberglass does not like to take 90-degree turns around the edge of a piece of wood, so it will have a radius to it. So that's our next step, is to get our other stringer formed and made, and then start